Now, solving for x inside of a logarithm, a and b, we can follow the steps as we did before, writing a single logarithm, using the definition, and then solving. But in a, there is a little shortcut. So I'm going to show you the shortcut, and then I'm going to show you what it would look like if you didn't use the shortcut. Okay? So in a, you start off thinking the same way. Simplify that so that you have a single logarithm. So I start simplifying. On the right-hand side, I have adding, so that would be the same as multiplying. And this shortcut only works if you have a log of something equals a log of something else. So notice at this point in the equation, I have on the left side log of 6x. And on the right side, I have log of x plus 6 times x minus 1. So I have a log equal to a log. If this side is equal to this side, does it make sense that what's inside the purple boxes has to be the same? Right? Because if you have log of something equals log of something, those two somethings have to be the same. So we are going to do sort of similar that we did in solving our exponential equations. When we got the bases the same, then we said, well, the exponents have to be the same. We went, so, dot, 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 and then said 6x is equal to x plus 6 times x minus 1. That's the shortcut. Going from here, well, I could expand this side. Notice it's a quadratic equation, so I make one side equal to 0. Try to factor. Does this factor? It does. So I get x equals 3 and x equals negative 2. So what did this shortcut do for us? It sort of skipped step 2. Usually we have to use the definition to write an exponential form. This time we got to skip that step, and we could go right into solving for x. Okay? Once you solved for x, you have to plug those back into your original equation to see if you ever take the logarithm of a negative number. So if we try positive 3, I'd have 18 there, positive 9 there, positive 2 there. Those happen to all work. If I try negative 2, 6 times negative 2, negative 12, right away I run into a problem. That's an extraneous root. So the only answer is x equals 3. If you didn't use the shortcut, so we had log 6x equals log, what was it originally? X plus 6. There's the original equation. Some students don't like to use the shortcut. In combining the logs, they say, the only way I can combine logs is if all the logs are on the same side. So the very first thing the student might do is say, I'm going to move the log 6x to the other side. Now all my logs are on the same side. And I have a log plus a log minus a log. I can combine those all together as a single log in one step. Whatever is positive will be in my numerator. Whatever is negative will be in my denominator. So now I've combined it to a single logarithm. The reason you get a single logarithm is so that, there's the green star, you can change it to exponential form. What's the base of this one? 10. What's the exponent? 0 equals the answer. X plus 6, x minus 1 over 6x. What's 10 to the 0? 1. I'm going to multiply this out. How would you get rid of that 6x on the bottom? Multiply both sides by 6x. And you get 6x equals x squared minus 5x minus 6. Now I'm going to zoom out here so you can see the entire page. Notice that this step here, 6x equals x squared minus 5x equals 6, is the same as we got there in the shortcut. How much shorter is the shortcut? Well, you saved all of this work by using the shortcut. Is the other way that much harder? No. You had to know how to change it to exponential form. You had to remember that when you had a rational equation like we do in this step where I multiplied both sides by 6x, that's how you get rid of your fraction. But that's something you did lots in grade 10 and in grade 11. And then from this purple step on, everything else would be the same. You'd still set it equal to 0, factor and solve, and figure it out from there. So you can only use that shortcut if you have both sides log equals a log. The shortcut doesn't work when you have a single number. Like we have the 3 here, it's not going to work to use the shortcut. Here you have to use the rules. So we have 2 logarithms. Can we combine them, simplify to get a single logarithm? Yes. We're adding, so we multiply. If I distribute that x, I'd get x squared plus 2x. Once I've got that single logarithm, this is where we want to use the definition to change it to exponential form. The base is 2, the exponent is 3, would equal x squared plus 2x. 2 to the 3 equals 8. Got a quadratic equation. How do we solve quadratic equations? Make one side equal to 0. And now we have to either factor or use the quadratic formula. Let's check if this factors. It does. And once again, after solving, you have to plug them back into the original equation. And in fact, at this point, I start to get a little bit mad at the textbook. Okay? And I'm going to tell you why at the end. But I'm going to plug in -4. Okay? Oh, -4 plus 2 is -2. Boom. You have one place where you have a negative inside of a logarithm. You don't have to keep checking. That one's extraneous. Plug in +2. 2 plus 2 is 4. That's okay. 2, positive. That's okay. X equals 2 is the only answer. Now, the reason I get mad at the textbook at this point is we have done 3 log questions in our notes. In question 1, we had 1 log question. And in question 2, we had 2 log questions. And after doing all 3 of them, a pattern emerged, which is a bad pattern that students fall into a trap. Notice that the negative number always canceled out. Notice the rule is you can't take the logarithm of a negative. The trap that students fall into is they see a negative number and they just go, oh, I just have to X out negative numbers. That is not true. It just so happened in this case that all three of those develop that pattern, and you might think if I get a negative number as my answer, I put an X through it. That's not true. I can make a question where I give you two positive answers and both don't work. I can make a question where you get two negative answers and they both work. I can make a question up where one of the answers is negative, one of them is positive, and only the negative one works. So it's not enough just to say, oh, it's a negative number, I'll cross it out. You have to plug it back into the original equation. So for example, let's say the original equation had a log of 5 minus x. And your two answers were x equals 9 and x equals negative 3. What happens if I plug in 9 into here? 5 minus 9 is negative 4. This one would be bad. What happens if you plug in negative 3? 5 minus a negative 3 would be positive 8. That one would be good. So just because the answer is negative doesn't mean that you have to cross it out. You have to check it in the original equation. So in order to give you practice, well, here, I'll give you the numbers for these ones. It's 11 and 13. We're going to skip example 3 because we did those yesterday. Well, we did similar ones yesterday.